Number 33. What is the cost of operating a 3-watt electric clock for a year if the cost of electricity is $0.09 per kilowatt hour? All right. So first thing is, start with what we need to calculate. We need to calculate the cost. What that means is that I want to find my final answer in terms of dollars. Okay, some dollar value. Notice all the other units must have canceled, meaning my years must have canceled, the watts, kilowatts, and the hours. All right, so you might already be noticing a relationship, right? These units probably are going to cancel with each other, and then these units are probably going to cancel with each other somehow. Okay, so let's first, now by the way, there are different pathways, right, to get to this answer. I'm going to take you down one pathway. There are multiple pathways. There's no right path, but there is one right answer. So this is just one of the paths. You might see it a different way, which is wonderful. As long as you end up with the correct answer, that's great. So let's first take this value of 3 watts and convert that into kilowatts. Why? Because I know I eventually need to cancel these units somehow. They have to be consistent in order for them to cancel, meaning they got to be the same. So I'm going to take my value of 3 watts, convert that into kilowatts. So kilowatts on the top, watts at the bottom, and remember that there's 1,000 watts in a kilowatt. All right. So now that leaves us with this value, 3 times 10 to the minus 3. That's in kilowatts. Okay, so that's one value. Now, let's convert. Now I notice I have, right, I'm running this electric clock that is requiring a rate of power consumption of 3 watts. And I'm running that clock for a year. So I notice that this year is a time value, and here I have a time value in my cost function in hours. So what I need to do is make them consistent. What I'm going to do is I'm going to convert a year into hours, meaning I want to know how many hours there are in a year. Okay, so that'll be the second part. So now let's do that. Let's take, so 1 year, converting this thing into hours. I know the relationship to days, right, from years to day. In 1 year, there's 365 days. So the years cancel. Leave me with days, but I don't want days, I want hours. So now I need to think, do I know a relationship between day and hour? And we do, right, that there's 24 hours in a day. So the days go bye-bye. And notice what we're left with. We're left with hours, right? So we take 365, multiply it by 24. So this works out to 8,760. So 8,760 hours in a year. Okay, great. So now I basically have consistency within these units. Okay, I got this time value in hours, and my cost function is also in hours. I also have my power value for the clock in kilowatts, and the cost function's power value is also in kilowatts. So now literally what I'm going to look to do. Okay, oh, one other thing before we do that. I'm just going to try to take this information and create a fraction out of it. All right? Just to make it a little easier. So let's take this and let's create a fraction out of it. Remember the word per kind of means divided by, right? So I can say this, that it's basically 9 cents, okay? Per kilowatt hour. All right, this is now somehow that turned into a triangle. This is now the cost function written as a fraction, all right? And this now will help us set up our dimensional analysis so that we can cancel all of our units. Remember, the goal here is to get just dollars in the numerator. I got to have everything else cancel, okay? So why don't we start with, I think it might be best, I'm just going to erase this for now. Why don't we start with this particular value here? Okay, and then we're going to place the other values accordingly. So why am I doing that? Well, remember, I know my value has to end in dollars, and it has to be in the numerator. So the only out of these three, out of this one, and this one, only one of those values has dollars in it. So I'm going to start with that because I know where that has to go. I know I have to have my dollar sign in the numerator. So I'm just going to write exactly what I see there, per kilowatt times hour. Okay, now what I'm going to look to do is now remember the whole goal is cancel the kilowatts, cancel the hours. So where shall we put this value? Well, it's going to be in the numerator, right? So I'm going to multiply, that can come next. So I'm going to now do multiplied by 3 times 10 to the minus 3 kilowatts, right? And if you wanted to, you could put this over 1. That's totally fine. But what's going to happen to the kilowatt? Take care, bye-bye, right? That all canceled. Now guess what the next step is? I got to get rid of hours. Oh, would you look at that? Yeah, I know what to do now. So just take this value, plug it on in. Hour, you could put it over 1 if you like, and look what happens to the hours. They cancel. And wait a minute, what's the unit that we're left with? Dollars. So let's calculate. So 0.09 times 3 times 10 to the minus 3 times 8760. So the cost of this now will be $2 and 36, well, 37 considering the rounding. 37 cents. That would be the cost of running, this clock if it costs 9 cents per kilowatt hour. All right. So guys, thanks so much for tuning in. Please remember to subscribe, and I'll see you in the next video. Have a great day.